So the session is about how you and your team of developers can be more productive during your daily debugging. If you're writing code, or if your team is writing code, chances are they're also debugging that code. At least I've never seen a job description where it says C# developer needed to write new code. Don't worry, we have another guy to debug it, right? So if you're writing code in Visual Studio, or if your team is writing code, then you're also fixing bugs. And sometimes we're lucky enough to work in an application where we can just write just a little bit of code, press F5, see what changes we made, and if there's something wrong, we kind of know exactly what we just changed. You know, that's a nice place to be. We don't always have that opportunity, though. So I find that's actually usually the exception to the rule. Usually what happens is one of these things. You're asked to fix a bug, and maybe this bug is part of the application that you didn't write. We work in large teams. I'm going to write one part of it. My colleague is going to write another part, so we're going to share the development effort. And then we're also going to share the testing and debugging effort. So I might have to work in his code that I've never seen before. I don't even know how it works. Or I might be asked to work on a bug that takes a long of time and plenty of steps to reproduce. I can't even remember how many times I've spent 10, 15 minutes setting up all of my necessary steps, my configuration, all my inputs, and then I'm right where I want to be, and I do step over instead of step into. And I'm like, OK, now I have to go from the beginning. I hate this. Or maybe you're joining a new team or a new project. I'm sure that those of you that can relate can remember how stressful it is to feel like you cannot be very productive because you just joined the team. You know how to code, you know how to debug, but you feel like you're not doing your best. And that's only because you're just not very familiar with the application or the team yet. Or it might be an application that you wrote a few months or a few years ago. I don't know about you guys, but every time I look at my code that I wrote a while back, I'm thinking, who wrote this? This is garbage. I would do it completely differently. Another type of issue that we have to usually deal with is somebody reports an issue. We try to reproduce it on our local machine, and no matter how hard we try, we can't reproduce it. So we keep spending a lot of time just hunting around for it. We can't even see it. Sometimes we see the bug, but we just don't know exactly how it happened. We play around with the application. We're maybe coding something new or fixing a different bug, and we notice something going wrong, and we don't even know how we got there. So out of curiosity, who here relates to at least one of these and has felt this before? OK, this is pretty much the entire room. OK, good. You're in the right session then. There's actually one more way that you can be more productive during your debugging with IntelliTrace outside of these core scenarios. And that is if you notice something that is completely unexpected behavior. This sounds like kind of magic right now, but I'll explain what I mean with an actual demo in just a few minutes. So let's talk about the agenda very quickly, give you a summary of what we're going to talk about. Just to make sure we're all on the same level of understanding, I'm going to go very quickly through what IntelliTrace does and how it can be useful to you. And then we're going to dive straight into the demo. This session is primarily demo, so most of it is going to be all of us working together inside the IDE. And the first demo is going to be debugging the same bug with and without IntelliTrace. And in order to keep me honest and make sure I don't tweak the demo to look great for IntelliTrace, you guys are going to help me debug without it, and I'm going to show you how I would debug it with IntelliTrace. And the purpose of this demo is not to get deep into every single UI element and every single option. What I'm actually going to do is I'm going to use IntelliTrace as if we all know how to use it. I'm going to go very quickly through it. And the idea behind that is I want you to get a feeling, an understanding of what's different. So what's different when I debug with and without IntelliTrace? And if I spend 15, 20 minutes explaining everything that I do and every UI element, it's going to take a lot longer, and you're going to be like, well, I don't really feel that was any faster. So if you have any questions about things that I used or things that I didn't use in the UI or some actions I did, I'm going to spend a lot of time in the second demo. Right after we recap on demo one, I'm going to spend a lot of time deep dive into IntelliTrace. We're going to talk about every option, every feature, every possibility, and then you can ask me any kind of questions that you might have at that point. Finally, I'm going to summarize what we've covered. I'm going to give you some resources, some links, and some other helpful tips for some stuff that we didn't exactly cover in this session. And we're going to end this with something that very people know. It's not a secret, but it's just a very little known fact. you guys can get in touch with any product team in Visual Studio directly. Without knowing who they are, you can just target the product team and give them either feedback that something that you used was great and you want to keep using it, don't change it, don't cut it, I want it. Or you can tell them about something that didn't work for you, or something that you want to change, or a crash report, or a bug, or just a scenario where you just have nothing available to you and you would like to see something in that space. So hopefully that will be interesting to everyone. Everybody happy with the agenda? All good? All right. So let's start with what can IntelliTrace do? What is IntelliTrace all about? IntelliTrace is kind of like a DVR for your debugging session. It's a recorder for your application. As your application is running, you don't have to do anything special. You just start up your application, and if you have IntelliTrace enabled, it will monitor it. And it will monitor it for interesting events. Now, what does that mean? Let's say that your application starts up and it reads a configuration file. That is considered an interesting event by IntelliTrace because file access could potentially lead to some interesting behavior. Let's say then the user performs a gesture like clicking on a button, scrolling a list, clicking on a tab, interaction between the user and the application. That's also considered interesting by IntelliTrace and it's recorded. Then let's say your application works with a WCF service or a database and executes some SQL. IntelliTrace considers that interesting as well because a lot of things can go wrong in the SQL that we execute. Maybe the parameters or the input is incorrect, or maybe the query isn't exactly what we expected. Maybe your application throws exceptions and catches exceptions. Sometimes those are OK, they're expected. Sometimes they're not OK. So again, IntelliTrace considers it interesting and records it. This is just examples of interesting events. I'm going to show you the full list later on. But your takeaway from here should be that when IntelliTrace detects these interesting events, it records them. It records the call stack the moment they happen, along with some local information. And then it allows you to go back in time and inspect the application as it was back then. So we'll see how that is actually really useful when you're debugging, because you no longer have to worry about placing the breakpoint at the right moment and at the right line. You can just let the bug reproduce. You can let the application work as it does. And when you see something that is interesting or something that you want to work on, you can just go back in time and inspect the state. So let's jump straight into the first demo, where you guys are going to help me debug this application without IntelliTrace first. And then I'm going to take over and debug it with IntelliTrace. Everybody can see the code? Great. So I'm just going to hit start, same as F5, so you guys can see the application we're working with. It's a very simple WPF text editor. All it does is allows you to open a text file. You can look at the contents. You can make edits. And then you can save it and close it. Very, very simple. So I'm going to do just that. I'm going to click the open button. And I'm going to open a file from the desktop. The contents of the file don't matter at all. So on purpose, I've put just kind of nonsense in it. But the bug I want to show you, the bug that we're going to work together to fix, is if I make some changes towards the end of the file, and then I click the Save button, my current cursor position is going to be lost. It's going to go to the top of the file, and so will my scroll bar. So I'm going to lose my current editing position. So I'm just going to click Save to show you that. You saw it jumped up to the top, and my cursor is before the very first character. So let's say we're all assigned this bug to fix. Where would you guys start first? Event handler of the save button, hit a breakpoint there. We all pretty much agree. That was definitely my first instinct as well. So let's go and do just that. I'm going to put a breakpoint right at the very first line of the button save file click. That's the event handler. I'm going to go back to the application and repeat my testing steps. It's a good thing that they're very easy to repeat. Otherwise, you get bored watching me do this. So click Save once more. And now we've hit the very first line in the event handler. We're at the breakpoint, haven't executed anything yet. I want to give you some time to read the code and tell me if anything looks suspicious to you, if you want to change something, or if you're happy with me just stepping through the code. Yes? Line 172, text file context.focus. I agree, that looks very suspicious. I've been bitten by focus events many, many times before. So let me just use edit and continue to change that line of code. I'm going to comment it out, so we're not going to run it. Anything else? That's usually the suggestion I get. That shows that you have some experience doing WinForms, and you've been bitten by this before. OK. So what I'm going to do is I'm going to step through this very slowly, just make sure there's no unexpected things happening, no exceptions or anything like that. So F10, the next line. All right, nothing too weird. We're going to open up the file here. Then we're going to get the contents of the text box, convert them into bytes. Seems fine. Then we're going to write the byte array to the file. Great. Our using statement is just going to close the file now. So that was fine. Everything executed without an exception. And we're at the end of the method. So I'm just going to F5 now and see if the code that we commented out was good enough. OK, unfortunately, I'm right back at the top of the file here. So that wasn't really the root cause of the bug. So what do we do next? I'm sorry, what was the suggestion? Look at the code and see if there's anything interesting in there? In the UI code? Any other suggestions of what you would do next? I'm sorry, what was that? Check for additional events. OK. So whenever I do this demo, the kind of feedback I get, the kind of suggestions I get is, well, we all were pretty quick to say event handler of the save button, because that's an obvious first place to go. We kind of saw that that's not where the bug is. So the next step is, well, we have to get a bit familiar with the code. We have to look for other events, maybe step through some code, maybe see what some variables are doing. In other words, we're not really sure what to do next. We're going to read some code, form a new hypothesis, put a new breakpoint somewhere, and repeat our testing steps again. And it's a good thing that these testing steps are really quick. So let me stop right here and show you how we can all solve this bug together using IntelliTrace without knowing anything more about the code. What I'm going to do is I'm going to just close the application. I'm going to get rid of this breakpoint, because I don't really need breakpoints when I'm using IntelliTrace. And I'm going to put this code back, because we all know that didn't make a difference. And I'm going to start debugging again, just normal. And I'm going to repeat my testing steps. I'm just going to open up the text file, go to the bottom, make some edits, click Save. My bug has been reproduced. Well, what I changed just before I showed you this demo is usually not usually, but by default in Visual Studio 2015, when you press F5 or start debugging your application, you get a brand new window called Diagnostics Tools automatically show up. Now, I had unpinned this window before the demo, because I didn't want you to see this window when we debugged without IntelliTrace. But now that I want to use IntelliTrace, I'm pinning it back. And because I want to inspect the events, the interesting events that IntelliTrace has collected for me, I'm going to hit the break all button. This is a limitation of IntelliTrace right now. It needs to be in a break state to show you everything that it has collected. We're working to make this experience not necessary to break. It's just as the application is running, you can see everything that it has collected. But for now, I'm going to use the break all button at the top of the toolbar. That's been there for quite a few versions, but not many people have use for it, so some of you might be seeing it for the first time. Basically, all it is it looks through every single thread my application has, and it puts a breakpoint. So wherever my thread is, it's going to stop. So I'm just going to hit that. My debugger says there wasn't any of your code running, but I'm not interested in that. I'm interested in the Diagnostics Tools window. So I'm going to go and look at my list of events that IntelliTrace has collected, and I can see them here in a tabular form. Just going from the top to the bottom, I can see I have 3 events which are modules being loaded into the application because I started debugging. That's normal. I'm not really interested in those. I don't really have any issues with the modules that were loaded. Right after that, I can see a clicked open gesture. That was me clicking the open button. That shows me the open file dialog. Then I have a file access event. That the file name points to the file that I opened with my open file dialog. So that makes sense, because when you open a file, first you access it, you get a handle to it, you read the bytes, and then you close it. So the access event is followed by a file close event. So far, so good. Nothing is suspicious here. Then I see my clicked save gesture. That's me making my edits and then clicking the save button. So this is where things start getting interesting, because that's about the time where a bug manifested. And then following that, what I can see is a file access, file close, and another file access, and another file close event. Now, that looks suspicious to me. I don't expect to get 4 file events. I expect to just get 2, because we saw the code. When you save the contents, first you open the file, write the bytes, and then you close the file. But instead, I'm getting open, close, open, and close. Now, at this point, I kind of already have a better hypothesis as to what is going on than I did before, where I had to go and look at the code. It looks like, for some reason, we save the changes, and then we re-access the file. And if I think about it, my mouse position gets reset, and my scroll bar gets reset. That's kind of like the behavior when I first opened the file. So maybe this is what's happening here. But I still don't know why. Now, let's be completely honest here. Some of you might be thinking, well, I have my favorite logging framework, Log4net or something along those lines, and I can get this kind of tracing information. And it's true. If you take the time to go through your code and put the right level of tracing in there, you can get something like this. It's not going to be integrated into Visual Studio, but you're going to get a text file that you can go through and filter through and try to find interesting events. But what a logging framework cannot do is answer the question, why? Why do I get 2 sets of events here when I'm expecting just 1? If I didn't have IntelliTrace, what I would do is I would try to put some breakpoints, repeat my testing steps, and see how many times this gets hit. Now what I can do is I can just click on the event, and then click Activate Historical Debugging. What that does is it sets the entire IDE in historical debugging mode. If you look at the very top of the title of Visual Studio, within brackets it says historical debugging. The text editor is actually showing me the line of code that was executed at that moment in time when that event was generated. No surprises here. We're in the event handler of the save button. We've seen this code before. And we're at the opening line of the using statement. Now, there's an info bar at the top of the text editor letting me know that there is more windows, there's more debugger windows that are participating in the historical debugging experience. So take a look at those for also historical data. So I can actually take a look at my call stack, and the call stack window itself says historical debugging. This is giving me the call stack at that moment in time. Now, this doesn't look interesting to me. We've been through this code. We know this works fine. I'm going to double check that the file close event is actually the end of this using statement. So I'm going to select that one and click Activate Historical Debugging. OK, takes me to the line of code. All right, nothing unexpected there. Now, this is where it gets interesting. I'm curious, where is the second file event coming from? Select that one, click Activate Historical Debugging. This one has taken me into the read file method. And that's completely unexpected. Why would I expect the file to be read after it's saved? I definitely don't expect that behavior. So my question now is, who is calling read file? I'm going to go back to my call stack window that is showing historical debugging data. And I'm going to see that the read file method was called by the open file method. Again, that doesn't give me any better understanding as to why it was called. So I'm going to go up one level. And I'll see that the method onFileChanged is actually calling open file. I'm not really sure what onFileChanged is, so I'm going to go up one more to what appears to be an anonymous method that is calling onFileChanged. So I'll double-click on that, just like I would with a normal live call stack. And it's going to take me up to the line of code that was responsible for that frame being added to the call stack. What I see here is that I'm in the event handler of a file system watcher. And the event gets fired, the file is changed, and what happens is on my onFileChange method, there is a bug where even when I save my own file and I detect my own changes, the application is reopening the file. Now, why does it do that? It's actually part of a different piece of functionality in the application. Because we're editing a file, the application is monitoring the file we're editing it. And if somebody else makes changes to the same file, we get a warning. Hey, if you save right now, you're going to be overriding somebody else's changes. But it looks like there's a bug here where our very own changes trigger this behavior, and our file gets reloaded. So like any good demo, the fix is in the comments. I'm just going to uncomment that. And I'm going to hit F5 to continue. And my application is running again. And I'm just going to repeat very quickly my testing steps to make sure that my bug is fixed. So I'll make some edits, click Save, and my current mouse position, my cursor position, and my scroll bar have been maintained. OK? Cool. So let's take just one slide's worth of time to go over what we just saw. Typically, when we're debugging, when we see a bug, we go through this iterative process of thinking, where can I put a breakpoint where it's not going to be too late to have already missed the root cause of the bug, but it's close enough to the root cause of the bug to give me the information I need to track it down. And we'll take a guess, we'll put a breakpoint, repeat our testing steps. Maybe we didn't hit it the first time, so we're going to go in this cycle quite a few times. And if you think about it, that's not a very good use of your time. If you're writing new code, you're actually adding value to your application because you're implementing a new feature. If you're adding unit tests, you're improving the stability, so your customers will feel like they have a better application. Even if you're refactoring your code, you're making it easier to write new code and to maintain the code. So again, you're adding value at any point in time. But when it comes to debugging, the only value is fixing the actual bug. The hunting for it, it's not really a very good use of your time. You want to get to the root cause as quickly as possible. So typically, without IntelliTrace, we see a bug. Our very first thought is, do I know the code well enough to go and put a breakpoint so I can start testing this out? Now, the difference when you have IntelliTrace is when you see a bug, your first thought should be, well, let's go and check out what IntelliTrace has collected for us. Maybe the root cause of the bug is right there, waiting for us to find it, like it was in the previous demo that we just saw. Even though none of us really knew the code any better, we could all see the weird behavior the application was making. We could all spot what was standing out as weird. Even if that wasn't the root cause of the bug, we would still want to fix that behavior because it's not expected. And let's say the bug is kind of tricky, and it's hiding somewhere in between those events, and you don't get really exactly straight into it. You're still getting a lot more information about how your application is behaving. So you can get to the root cause of the bug easier by eliminating certain scenarios. You can see that some things didn't happen, so you don't have to worry about them. Overall, we're spending less time hunting for the bug, and we're focusing exactly on the root cause and fixing it quickly. Any questions so far before I dive into the deep dive? Yes, please. So the question was, there are some events that you saw, the file access and the button click, but what about some other events that are interesting to me? For example, when a property gets accessed and changed by multiple people. I'm going to defer to my second part and a second demo where I show you how you can add your own events into IntelliTrace, and that case can be catered for like that. Okay. Any more questions? Yes? You So the question is, can I actually record my application execution on an environment where I cannot have Visual Studio? So I cannot just F5 my application. Instead, the application is running in a production or testing or QA environment, and I know there is something happening there, and I cannot reproduce it anything else. And I'm going to show you how you, the answer is yes, and I'm going to show you how you can do that in my second demo too. I'm going to get one more question, and then go to deep dive. The answer is no, and I'm going to show you exactly what that filter does. Sorry, the question was, when I filter by thread, does it also filter the call stack? Some of you might not really know what that means. I'm going to show you how you can filter events by thread in the second demo. And the answer to that question is no, you cannot filter the call stack by that thread. But let me defer some questions until after the second demo. Even if I don't get to all of your questions right now, I'm going to, after the demo, my session is done, I'm going to pack up and step on the side, and I'm going to be here for any questions you guys might have. So even if I don't call on you with your hand up, don't worry, we're going to still talk about whatever is concerning you later on. So let me jump into the second demo, where I'm going to take my time here, and I'm going to actually explain to you what I used, all of the IntelliTrace options and UI that we have available. So this time, we're going to work with a different application. I basically wanted to work with something a bit more complicated than the previous demo. The previous demo was a very simple application just to make you get the feeling of how it is to fix a bug with IntelliTrace versus non-IntelliTrace. This demo is using an application that I found on CodePlex. It's not a very sexy application. It's kind of old, and it uses WinForms. But everything that you see here applies across all managed applications, WPF, ASP.NET, WCF. And the reason why I chose it is because it's a bit more complicated than just opening a file. And it uses ADO.NET to communicate with a database, which is also interesting. So I'm going to click the login button here to open up the application. And it's basically a little app that is used to manage a social club. You can register new members, you can query your list of members, and you can update them. And it's using a database as the backstore. So I'm going to do just that. I'm going to register myself as a new member, if I can spell my own name. This is not my real birthday, just so you guys know. I'm going to select the occupation and marital status. And let's be honest, I can lose some weight. So let's click on the register button now. And that's just using Entity Framework to make sure that the right database tables are there. It does the initialization of the database. Now it says my registration was successful. So I'm going to click the second tab. And this is the tab where the application allows me to search and update my existing members. And the bug I have been asked to look at is that the getAll search functionality is behaving weird. It's sometimes returning records that people claim they didn't insert them. So let me click getAll and see what happens. So what I see here is I have two records being returned. The first record is the one I inserted, and it looks like all the data fields are correct. And the second record seems to have some empty fields, some default values, and some unknown values. And I definitely didn't insert that record. And this is completely unexpected. This is return. I was only expecting to get myself back. Now, at this point, immediately my brain goes to, well, I wonder if the bug is where I inserted the first record and inserted two of them, or is it that the getAll is doing something weird and the query isn't right and is returning more records than it should. The application has an extra search capability. You can search specifically for an occupation and a marital status. So I'm going to use that to see if I can select that second record. Because if that's returned, that will make me think that's a real record that was inserted at the time of registration. So I'm going to select occupation of unknown and marital status of unknown, and I'm going to search on that and see what that returns. Well, that's just completely confusing now. That returned the first record that has an occupation of engineer and married. So now I'm thinking maybe there's something wrong with these drop-down boxes, and maybe the mapping between the values in the drop-down box and the values in the database. Basically, I'm not really sure where the bug is right now. Now, I don't know the code very well, and I've did quite a few things in the application, even when the bug was manifested. I'm going to go back into Visual Studio, and I'm going to hit the break all button again, just so I stop wherever I am. It just so happens that in WinForms, you have this loop that keeps on running while your application is idle. So the debugger took me to that line of code because nothing else was running. And now let's focus on the Diagnostics Tools window. This Diagnostics Tools window is a brand new window in Visual Studio 2015. Those of you that have used IntelliTrace in the past might remember that we used to have a different UI. It was a window that was competing for space with Solution Explorer. That UI is now history. It doesn't exist anymore. IntelliTrace has been integrated into this new Diagnostics Tools window. Along with IntelliTrace, you have the CPU and the memory tool. And I'm not going to have time to talk about those in this session. Those are two tools that are available across all SKUs. I'm going to have a link at the end of my slides where you can go and learn more about those great tools, which basically allow you to monitor the performance of your application while your application is being debugged. You can see how that, combined with IntelliTrace, can give you a very complete picture of how your application is behaving, not just in terms of logic, but also in terms of performance and what resources it's using. Now, you saw me click around in this list below, which I'm sure we all by now realize it's where IntelliTrace is showing me every event it has collected. In the old UI, we had a flat list. In this new UI, we have a tabular view that allows you to get access to more data at the same time. Usually, I make this event column bigger so that the demos, you can actually read the events. But this is a pretty low resolution on a multi-monitor setup or in a higher resolution, you can have all these columns visible. The other columns that you have here are time, duration, and thread, and I'm going to talk through all of these. Thread is pretty straightforward. It's basically what thread was responsible for generating that event. In other words, what thread executed the line of code that this event represents. Duration is only applicable to break events. How many of you here know about perf tips? Oh, not a lot of people. Okay. Let's fix that real quick, because perf tips is awesome. Let me break protocol here. And let me go to my first demo. I'm going to fire that one up. And I'm going to open up a file. And I'm going to make some changes, hit save. Now, I've hit this breakpoint, and all I'm going to do is I'm going to press F10. Can you guys see that right next to my current instruction pointer, there's a little what we call perf tip that says 1 ms elapsed? That is basically timing my code between break state. So if it's between two breakpoints, or if it's stepping or run to cursor, whatever code was executed between them is going to get timed for me. So it's going to tell me how much time was elapsed. This is what we call perf tips, and a very frequent ask is, that's great information, but if I step again, the perf tip goes away and I see the new perf tip, and I would like to remember what the old one was. Well, that's what the duration column here is for. For every break event, you're going to get the same number as the perf tip. It's going to be stored in this column. So that's kind of like a history of your perf tips. I highly recommend that you go and check out the blog post that I have at the end of my talk to get some more information about perf tips and the other tools within Diagnostics Tools window, because it's going to make your life a lot easier. Then you have the time column. The time column is basically when did this event happen in relation to the very beginning of my diagnostic session. And if you look at the very top here, just underneath our toolbar, there is a diagnostic session counter. It's telling me that I had a diagnostic session running for 3 minutes and 23 seconds. And you probably noticed that the time is paused right now. The Diagnostics Tools window is only interesting in what your application does while it's being executed. So whenever you're in a break mode and you're taking your time to investigate state and add watches and all that kind of stuff, it pauses, and you don't have to worry about it. You can take your time. You can take 20 minutes in a break state. As soon as I press F5, my application resumes. The counter will start counting again. As soon as you hit another breakpoint or you break all, it's going to pause again. Now, what I didn't talk to at all before was, what is this view up here, this timeline view up here, and what do all of these little glyphs represent? Exactly the same data that appears in this detail list before, this detail table view below, exactly the same data, exactly the same events, are being represented as a timeline at the very top of the window. And the events have been split into 3 types. So there's 3 tracks in this timeline. The first one is break events. This is every breakpoint being hit, every step being recorded, every break all. Basically, every time that the debugger stops execution of your application, an event represents that and appears on this timeline track. The reason why it actually looks like a long rectangle is because we're trying to represent the perf tip. We're trying to show you the duration between the previous break state and this one, so you can see how they relate to each other in terms of size. The second track is the output events. This is messages that would typically go to the output window, things like console.write line, threads exiting, process exiting. IntelliTrace in 2015 collects those things we didn't used to do before and shows them here on the timeline, so you can get an understanding of how they're happening in relation to other events and in relation to your breakpoints. And finally, the last timeline track is the IntelliTrace events track. Basically, anything else that doesn't go to the other 2 tracks goes here. From what we saw, things like file access, A.NET events, they all go here. Now, what is the purpose of this view? The idea is that as your application is executing, you might be doing a lot of things. A lot of things might be happening. And at some point, you need to orient yourself, because IntelliTrace may have collected a whole bunch of data. Now, in the previous UI, you didn't really have any other option in previous versions of Visual Studio other than just going through the list and you doing your own kind of orientation by finding an event that you recognized. What we can do with this timeline is every event is represented as a glyph. So in this example, we ran the application for quite a bit. We did one search, we did another search, so we don't really know what the bug is. We want to start taking it bit by bit. Like I said before, one of my hypotheses was that maybe at time of registration there was a problem. Another hypothesis was maybe my get all didn't work correctly. So I don't want to focus on the whole thing. I want to split it up. So I'm just going to use my mouse and go hover over the events in the timeline just to get an idea of what is happening, what are they representing, and how did things happen over time. This first event says this is the gesture for clicking login. That's just at the very beginning. I click the login screen. Not very important. I move on to this next kind of cluster of events, and I see that the tooltip tells me that this is the event of me clicking the register button. So there's quite a few events around this area. This is probably everything that IntelliTrace collected at time of clicking the register. Then, because I'm a human being and I'm talking, I took some time to click on the other tab and click the get all. And if I move my mouse over to the next cluster of events, this is me clicking get all. Now, I want to kind of divvy up here. I said I want to focus on maybe the registration process first, because I don't know where the bug is. So I'm going to left mouse click and drag, which allows me to select time. Now, what I've done here is I've selected this, I've sliced my timeline down to this time, and I can do right-click, zoom to selection, which will zoom me in so I can see more events that happen really close to each other. And at the same time, what this does is it filters my tabular view below just to this time slice. So my tabular view no longer has the events that happened after it, me clicking the get all, and it doesn't have the events that happened before it, me clicking the register button. So I've sliced up my time to what happened when I clicked register, and now my tabular view has been filtered accordingly. What I'm going to do is I'm just going to take a look at these events, and immediately what catches my attention is right at the very end, I can see there's two insert statements. And that's not usually that suspicious, but it looks like there's two insert statements inside the same table, club members. So I don't know if this is the root cause of the bug. It certainly looks suspicious, and I want to look into it anyway because I don't expect two insert statements on the same table for one button click. So let's take a look at that. I'm going to click on the very first event. And because this is an ADO.NET event, I actually get to see the SQL that was executed. So this is Entity Framework. So right after it does the insert, it also does a quick select to get the ID of the record that was inserted. That's why you see that the text command has an insert followed by select. And I'm curious as to how this gets called, so I'm going to click Activate Historical Debugging. So the text editor takes me into the create method. And if I look at my historical call stack, I can see that the method is called by another method called register member. And from register membered is called from register_click, which I believe is the event handler. Let me double click on that one. So this is the event handler of the register button. This looks fine, nothing suspicious here. Now I want to compare this to the other event. So I'm going to select the second insert event, activate historical debugging in that one. Now, if you are paying really close attention to the text, there's already a clue here because in my SQL statement, I can see that some of the parameters are null. And if I remember correctly, some of the record, the second record that wasn't useful, that wasn't the one that I was expecting, had some values, but some of them were completely empty. So pretty sure this is the root cause of the bug here. But let's find out where this is coming from. Clicking Activate Historical Debugging took me exactly to the same method as before, the create method. But let's take a look at the call stack of this event. Again, it's getting called by the same register member method. So far, so good. But then I see that that one is called by button register _ mouse click. So if I double click on that one, that is actually taking me to a different event handler for the same button. So that's just a very silly bug. I don't know if you guys have worked with WinForms before. It's very easy to just accidentally have two event handlers for the same button click. So what's happening here is I added some functionality. Maybe one of my teammates added the same kind of functionality, so the same code gets called twice by one mouse click. Now, This got me to the root cause of the bug really quickly, but I didn't use absolutely every single piece of functionality I had available to me. So let me take you through some of the other options you have. What I said before was that the types of events that IntelliTrace considers interesting was just a little sample. If you want to get to the full list, you just go to Tools, Options, IntelliTrace, and then the sub-tab IntelliTrace Events. This is a list of every type of event that you can turn on or off that IntelliTrace will consider interesting and collect an event for it. Now, a lot of people ask me, what is the performance overhead of IntelliTrace? What do you recommend? How do we use it? The idea behind IntelliTrace is that you always keep it on. Now, immediately when I say that, you're worried, how much is that going to slow down my debugging? I wish I could give you an answer that was 3 milliseconds. But the answer really depends on how your code is behaving and what events you've turned on. So there is an overhead with collecting every event. It's really tiny. It is really just a few milliseconds. But you can imagine if you have an application that constantly does 1,000 SQL calls and you add just a couple of milliseconds to that, that's going to end up to being 2 seconds. So it really depends on what events you've turned on and how often your application is generating them. Does that make sense? Any questions on that aspect? OK, good. I'm glad that's clear. So we've turned on some by default. Oh, please, there's no question right there.
You said before that this would be usable in production or hinted at that.
I'm getting at that.
OK. Well, you just kind of contradicts that.
I'll get to that. So here we have some events that are selected, turned on for collection by default. Feel free to turn more on if you think they will be useful for your application. But you don't have to make your choice here as far as how much noise and how many events you get. You can turn as many events on at collection time as you want. And if later on you think some of them are not useful to you, you can just filter them out of view after they have been collected. So what I can do here is I can actually change my view to show me only A.NET events and nothing else. You can see this has been filtered down just to SQL now. And I can do the same with the thread filtering. If I know that I'm only interested in the behavior of a particular thread, then I can filter the list to show me only events that have been generated by that thread. So that's what the thread filtering actually does. It filters the list of events by the thread that created them. Now, you'll also see a hyperlink right next to these two drop-down boxes called Show Events from External Code. This is a new feature in 2015 for IntelliTrace. How many of you here are aware of the Just My Code debugger option? OK, quite a few. The Just My Code option for the debugger basically says, if I don't have symbols loaded for a particular assembly, I'm going to assume that's not your code, that you don't own it. So when I want to show you information, I'm going to try and omit information for those assemblies. In other words, for IntelliTrace, what that means is, if another assembly that you didn't write generates events like file access, A.NET, exceptions, you're not going to get to see them in this list. If you want them, you can click on it. But by default, we filter those out because we're assuming it's not your code. There's nothing you can do about it. It's probably not interesting to you, so it's adding lots of noise. Yes? They're still collected, but they're being filtered out from your view. OK. Now, any questions so far before I move on to the next demo? OK, pretty good. I'm going to jump on straight ahead to the next demo. What I'm going to show you here is a different application. This is an ASP.NET application. It's pretty simple in its functionality, kind of similar to before. It's a contact manager. I can add contacts and change them and remove them. And what I've been told is after you use the application for a little bit, the edit functionality doesn't work very well. So what I'm going to do is I'm going to go ahead and just register a new member. Sorry. Just so I can make it work a little bit. That's all it does, really. I'm going to save a couple of people. Then I'm going to remove a few people. And then I'm going to click Edit. Oh, who forgets breakpoints in their code, right? Never. I'm going to unpin that. So I was trying to fix an issue with Edit. But just by looking at my diagnostics tools window, I can see in my list of events, and up here in the timeline, some red events. So immediately, my attention is caught at these red events. I move my mouse over, and it says there's an exception being thrown. I didn't do anything that I expected an exception was worth throwing for. I just saved a couple of people and then deleted them. So I'm just going to select time around them and take a look. My tabular view has been filtered. And what I can see here is there is an event for an exception being thrown. If I click on it, it has a message. It says, you cannot have two contacts with the same email. And if I click Activate Historical Debugging, it takes me to the add contact method that actually makes sure there is no existing contact with the same email. Now, my UI didn't tell me anything went wrong when I saved contacts with the same email. So clearly, I'm missing some validation on the client side. And I wasn't even looking for this issue. It just happened to show up as I was going to look at the edit functionality. So this is what I meant by saying you can be more productive during your debugging by finding things and behavior that is completely unexpected and you're not even looking for. All I did here was just look at my timeline. I saw something red. Red means exception. I didn't expect exceptions, so I went to take a look. Now think about how this bug would actually be filed by a user. Now, it was pretty quick for us to find this, click Activate Historical Debugging. Immediately, we know exactly what's wrong. We know there's some validation missing in the UI. But if a user filed this bug, they would probably say something like, after I save some users and I log out and I log back in, they're missing. That would be my repro step. You wouldn't really know where to start. Chances are you probably wouldn't use the same email address. You may have some test data already in your system. They all use different addresses. You do add and remove. Nothing goes wrong. And you spend some time trying to figure this out. But with IntelliTrace, it just took you to the root cause of a bug that you didn't even know was there. So that's another way that IntelliTrace can help you be more productive. You don't have to even wait to file the bug and work on it and figure out, decipher the repro steps. And I completely lied to you. There is no edit functionality here. That was just an excuse to hit that breakpoint. Now, let's talk about a different scenario where, out of curiosity, how many here write asynchronous code? Async await. OK, about half the room. So let me show you something that is quite annoying when you write async code. And those of you who do will immediately feel the pain, remember the pain. I have a very simple WPF application here. It has only one button. It's not meant to do anything other than demonstrate what I'm about to show you. I'm going to click on it. And Visual Studio breaks and tells me that there is a null reference exception being thrown. And it points me to this line of code, await manager.manage something. Now, I can see in the line above, I'm initializing the manager, so what's null? If I move over the manager, it's not null. Even if I go inside this manage something, there's nothing null here. So why is the debugger actually showing me that the exception happened at this line of code? Basically, when an exception is being thrown during async code, the debugger cannot, right now at least, cannot tell you exactly where that exception was thrown. There is a good reason for that. We're working to improve that experience. But unfortunately, for now, that's just the case. So when this happens, you're kind of out of luck. You don't really know where the exception happened. Well, with IntelliTrace, you can just go to the list of events, find the exception thrown event, click on Activate Historical Debugging, and it takes you straight to the line of code that was responsible for that exception, whether it was async code or not. Sounds pretty good? Good. Now, the other thing I want to show you about exceptions is the one I showed you before about the swallowed exception. Now, we said that the problem was the UI was missing some validation. If I add the validation to make sure that the email address is unique, then the user can get a warning ahead of time before we actually throw the exception. But what about if the exception was being thrown for good reason? In that case, that part is fine. What's really interesting is how your exception handling is working. So I just did exactly the same thing as before. I repeated basically the same steps, and I'm hitting break all. And what I've got here is the same exception as before. Only what I want to ask you now is, do you know where this exception was handled? It was clearly swallowed by the by my code because I never got an error anywhere, how would you go about finding out where it was handled? Any ideas? There is actually a way without IntelliTrace, but I'm curious if you guys have used it before. So there is actually a feature that I'm going to show you right now under Debug, Windows, Exception Settings. This allows, this is a brand new window, by the way. For those of you who have used it before, it used to be a modal dialog, and it had quite a bit of nastiness in it. We've redesigned it a bit, made it much quicker to show up and so on. But what you can do here is you can actually add an exception to this list, check the box, and say, every time this exception is thrown, please break. And that's great if your application doesn't throw too many of them, and it's not OK to throw them. But if it does, like if you have a complex application and it's normal to throw and cut some exceptions, this is going to be very annoying, right? You don't want to break every time this exception happens if it's not the one that you want. So instead, with IntelliTrace, what you can do is you can click on the code, the exception code event, click Activate Historical Debugging on that one, and it actually takes you to the exception handler for the exception that was thrown before. So usually when you have a swallowed exception, you have two issues to fix. One is, why didn't my UI warn me about it, and it got swallowed? And the other one is, well, when it does happen next time, and if it's for a good reason, I want to know why. And I want to know where my handling went wrong. So IntelliTrace helps you get straight to the catch handler. All right. Any questions so far? OK. All right. I'm going to keep going. So now what I'm going to show you is how you can actually use this on a production or QA environment. I think I've been asked a couple of times. It's actually really, really simple. The IntelliTrace is integrated to Visual Studio, so as soon as you hit F5, it starts collecting. But if you're in an environment where you cannot afford to have Visual Studio installed there, you can actually X-copy, which means there's no installation required. You can just copy-paste the files onto the machine where you cannot have Visual Studio installed, just the IntelliTrace collector. We call this the IntelliTrace standalone collector. There's two ways you can get access to it. You can either use your favorite search engine and just search for IntelliTrace standalone collector, and it's a download on the Microsoft site. Or if you're on a machine that has Visual Studio installed, you can just go to your installation folder, and I'm showing it to you right here at the very top. It's Visual Studio, Common 7, IDE, Common Extensions, Microsoft, IntelliTrace, and then the version of Visual Studio that you have. And you will find a little cab file, IntelliTrace collector.cab. That's all that you need. That's also exactly the same thing that you're going to get from the download. So the next step is, because I've already downloaded, and I already have it here on my desk ready to use. So we're going to pretend that this is exactly the same as you're doing download this on the server. So now that you have the cab, the first thing that you need to do is you need to extract it. By the way, all of these instructions, I have a link to a blog post that explains them, plus they're on the download side. So I didn't just come up with them. They're documented there, so you can follow them. So what I need to do is do you guys know how you can, if you hold down Shift and right-click, you get a cool little option, open command prompt here? That's really handy. So I'm opening up a command prompt right on that folder. And I'm just going to expand the cab file. And it's really important to have the little dot at the very end that makes sure that the structure is the same. File structure remains correct. So that's going to go ahead and extract my cab. And like I said, admins shouldn't be too worried about this because there's no installation required. There's no MSI here. And the next thing that I have to do, now that everything has been extracted, and I'll show you in the directory that was before, it's just a whole bunch of files being extracted in directories. Okay. What I'm going to do is I'm going to use one. First of all, I'm going to switch to PowerShell. Just type PowerShell, press Enter. Now I'm in PowerShell mode. And I'm going to use the import module command to import into PowerShell the ability to start the collector and stop. So I'm going to right-click and paste my import module command that just points to this DLL that was just extracted. If I go back to my extracted archive, I'm just pointing it to the Microsoft.Visual Studio IntelliTrace PowerShell.dll. Just going to press enter. Now PowerShell has the ability to execute IntelliTrace collector commands to start and stop collection. And at this point, you have a choice to make. If you want to monitor an ASP.NET application, you're going to say start collection, and you're going to provide the app pool, maybe a few more parameters, depending on how your app pool is configured. If you want to monitor a SharePoint application, you pass in the word SharePoint, the port that your SharePoint server is listening at, and a couple more parameters. And in this example, what I want to do is I want to actually use the same the same WinForms application I used before. So all I have to do is pass it the path to the executable. So it just depends on what type of application you want to monitor. And this doesn't look great, so let me just talk through it on Notepad, actually. The very first part is just the IntelliTrace standalone collector exe. You say launch as the parameter. You say /CP, and you provide what we call the collection plan. So what the collection plan is, basically this. The collection plan, it's basically the input into the standalone collector that tells it what events should it consider interesting and record. There's a couple more options that I didn't show you here before that it's a good time to show you since it's more relevant to the production environment. Aside from just picking the list of events, you can also do some whitelist or blacklist filtering based on certain modules. So you can provide either a wildcard or an exact name of an assembly, and you can treat this list either as a whitelist or a blacklist. Basically, you can tell IntelliTrace, collect events only from these assemblies, or make sure you never collect events from these assemblies. This is where you can put some of your third-party libraries, or maybe some modules that you know for sure there's nothing wrong with them and you don't want to have the noise of collecting events from them. So we're passing, these options all get persisted into an XML file. And we're basically getting the download, the cab actually has a default file in there for you. You can either change that by hand, which is really tough, I wouldn't recommend it. Or instead, what you can use is the community has created an editor for this XML file that looks very similar to Visual Studio. So let me show you that, because that's actually really handy. You can find it on Codeplex if you just search for IntelliTrace collection plan editor. I also have a link to a blog post where I've blogged about it. But let me show you what that looks like. I have it installed, and if I just double-click on it, it's a standalone application. It lets me open a collection plan, if I just do file open. And then it lets me edit it just like you would within Visual Studio. This is the list of events. This is the list of modules you can whitelist and blacklist. So you don't have to manually edit the collection plan. You can do it with this useful tool. Then you save it. Once you have that prepared, that's just the argument to launching the standalone collector. Then you're going to tell it where do you want it to save the results. So basically, the way the standalone collector is this. It's going to run in production. Your application is going to execute. Whenever you're happy that you've collected all the information that you wanted to collect, you can tell it to stop collecting. As soon as the standalone collector is done, what it will do is it will generate what we call an ITrace file. Basically, everything it has collected is saved to this file that you can then copy into your development environment where you have Visual Studio and just do file open. Once you do file open, you're going to get an experience very similar to what you had during F5. The only difference is you're not going to have the top timeline because we don't have break events and we don't have output events in production. That's going to be the only difference. Yes, please.
For this to work, is the production has to have the PDBs?
So I'm really glad that you asked this question because I answered it incorrectly in the build event last week, and I want to set the record straight. You don't need to have the PDBs on the server at collection time. You just need to have the PDBs on your local machine, on your dev machine, when you open the ITrace file so that you can get the correct line source code navigation. Yes, please.
Will this work with Azure websites? Web apps, as they're called
Yes, it does work with Azure. It's part of deploying an application to Azure. There's a little option that says enable IntelliTrace collection.
Okay.
Yes.
For a web application on IIS that you're hosting on-premise, I'm assuming it needs to be run on the web server. And what type of permissions do you need to be able to run it?
So the question was, if you have an ASP.NET application running on IIS, can you use this for that? And then what kind of security permissions do you need? The answer is yes. You just have to give it the name of the app pool that your application is running under. And here's where it's pretty straightforward, but it gets interesting. The collector needs to run with enough privileges so that it can access the app pool. Now, if the app pool is running under an Active Directory account, then the standalone collector needs to also be executed under an Active Directory account for this very simple fact. A local account cannot access the Active Directory to make the check. So if you run it as a local admin, but the app pool is running as an Active Directory admin, that's going to fail because we cannot even check the permissions on Active Directory. Does that answer the question? Okay. Any more questions? I'll take one more.
Before the events are written to the ITrace file, are they stored in memory?
That's right. But so the question was, in production with a standalone collector, before they're written to the file, are they stored in memory? Not all of them. The standalone collector is not going to add to the memory pressure of the server. It has some memory buffer. It's optimized to make sure we don't trash your disk either. So it has a little balance. It keeps some in memory, batches them up, and writes them to disk, making sure it doesn't use up too much of your memory or your disk.
What are the space requirements around that?
The question was, what are the space requirements for the ITrace file? You can either let it go and grow as big as you want it, or you can specify a size. That's part of the collection plan. The little utility lets you do that. You can specify a size, say don't take more than 500 megabytes, and then what it will do is will act as a rolling buffer. So after the 500 megabytes are used, it's going to start writing from the beginning, so you're going to lose the very first events to get the latest ones. I don't have much time left, so I'm going to keep going very quickly. And like I said, I'm here to take even more questions from you later on. So let me go back to the deck. And do a quick summary of what we covered. So for those of you that had seen IntelliTrace before, you saw how there's a brand new UI within Visual Studio 2015 integrated with diagnostics tools. There's more tools, part of this window, that I didn't have a chance to talk to now. I'm going to show you a link to go and read up on those because they're great, great features. We saw how with IntelliTrace, we can save time during debugging. We can improve on our workflow and spend less time handing down the bug. We saw how if we just keep IntelliTrace monitoring our application, even when things happen that we didn't expect, we can detect unexpected behavior and save ourselves time, save ourselves even bugs being filed in the first place. We saw how IntelliTrace is a great tool for detecting swallowed exceptions. This is a very typical scenario when you're dealing with client-server, where you forget to have some validation on the client side and the server is swallowing exceptions. We can see how with IntelliTrace you can monitor both the client and the server and make sure no unexpected exceptions happen and they're not swallowed. We saw how IntelliTrace can do pretty much something that no other tool can do, which is it can tell you how an exception was handled. It can take you to the exact place where the catch happened, even if it's not in the same file or even module. We saw how right now debugging exceptions in async code can be a bit of a pain, and how IntelliTrace can take you straight to the line of code that was responsible for throwing an exception when you have it executing asynchronously. I didn't have a lot of time. I'm sorry, I didn't have time to show you how to add your own events. If I'm done and I still have some time, I'll try and do it, but basically it's as simple as this. You go and put a breakpoint. The new UI in Visual Studio 2015 allows you to say, as an action of a breakpoint, continue execution. Basically what that makes it do is when the line of code is hit, it's not going to pause the debugger. Now, why would you want to do that? Because you also have the option to output a message. So let me just do it real quickly. I'm not going to be able to run through it, but you're going to get the idea. So I just had a new breakpoint. I clicked on settings. Thank you. I put a breakpoint. I clicked on, put a breakpoint, clicked on Settings, and this is the new Pick UI window for exceptions. You get two options, conditions and actions. Conditions is about how this breakpoint should be hit. You can have a hit count or a filter condition here. That's not what's important for custom events. If you click on actions, what you get is the ability to log a message to the output window and to continue execution. Now here, I can either just type normal text, the value of E is, and if I open curly braces, a curly bracket, I can actually type code in here, so I can access local variables. So I can actually put here E, which is my mouse event args, dot get type, or any kind of code that won't be executed. So basically, you can add these, as we call them, trace points. They're not breakpoints because they don't break the execution. They're trace points because the debugger is going to run through the line of code, execute this whatever output message I want in the output window. IntelliTrace is going to collect that, and it's going to show you as a custom event that you added to your code, but the code is going to continue running immediately. So as far as your application is concerned, you just added some tracing to it, and IntelliTrace is picking that up as a custom event. Okay? And we also saw how you can collect data from production without Visual Studio. That starts with a standalone collector. And I want to spend just a few seconds to tell you about something really cool that one of our customers has done. He basically has an application that is a WinForms application. And he wants to have reports from his users immediately as soon as they happen. So what he's done is he created a bootstrapper. This bootstrapper calls the standalone collector, and the standalone collector actually calls his application. So if the application crashes at any point in time, the standalone collector generates the ITrace file, and the bootstrapper says, oh, the collector just generated an ITrace file. I'm going to email it back to the developer. So very often, he has fixed the bug and sent out an update before his own users have reported the bug to him. So that's a pretty cool use of the standalone collector. You can see you can combine it with many different things. You can even combine it in a QA environment for testing. So a few resources for you. Anything that comes out of Visual Studio Diagnostics, so anything to do with the debugger, the profiler, IntelliTrace, everything is being blogged about, whether it's an improvement to an existing feature or a brand new feature. So if you want to keep up to date, we don't usually spam through this blog. We don't put things that are advertisements. We usually talk about real work and real new features. So I recommend you subscribe to that and you keep up to date with the latest improvements. Things like the perf tips, CPU memory tool, and all that kind of stuff I talked to you about always gets blogged about there. If you want to know more about the diagnostics tools window, the other tools that you have available there, like the memory tool and the CPU tool, please check out this blog post by Dan Taylor. It explains how to use it, and it has links to other walkthroughs and videos that you can watch. And finally, if you go to the blog post for the IntelliTrace standalone collector, if you bookmark that, I always update it to have the latest link to the download site. It has instructions, some explanations of how to use it. So if that's your starting point, you can find all the resources, whether it's to download it or configure it. Yes, please, Carson. What version of Visual Studio do you need to get for what? So IntelliTrace in 2010, 12, and 13 is available in the Ultimate Edition. From 2015 onwards, it's available in the Enterprise Edition. So finally, what I promised you is how you can get in touch with any Visual Studio product team. And little does anyone know that when you use the Send a Smile feature, do you guys know what I mean by Send a Smile? Yeah. When you use the Send a Smile feature, whether it's a positive, a smile, or whether it's a negative, a frown, if you put the right keywords in there, so for example, if you type IntelliTrace, that feedback goes directly to the product team. So for IntelliTrace, that goes to me. If you type debugger, that goes to Andrew Hall that sits right here, who's the PM for the debugger. If you type in profiler, it will go to that appropriate person. Now, we really want your feedback, whether that's for a bug or a thing that doesn't work. But more importantly, we really need your feedback for features that work really well for you. Because I don't know if any of you have felt the pain of using a feature and discovering that in the next version of Visual Studio it has changed, or it's been cut completely. We're not evil. We're not trying to take away features that you guys like. It's just that we probably didn't know that you used it. So if you send us the feedback that, hey, this worked great for me, please add this, or keep it around, or just give us some feedback that you're using it, then we collect all of that data. Even if we don't respond to you every single time, we always read it and collect it. And if it's a bug report, and you give us your email address, we'll probably contact you directly. If it's just a feature, then we're going to make note of the feature that you want. We may ask you to go and vote on user voice. If you look at the very last point on my slide here, there's a link to go to vote on user voice for features that you think that you want to make the next version of Visual Studio, and other people can vote on your suggestions. So often what we do is if we get lots of people asking for one thing, we're going to go to user feedback, create an item for you, and then email you back and ask you to go vote. Well, you can do that yourselves, right? You can just go add a suggestion and ask people to vote, and we always go and look at that site. And we get an idea of how much something is needed over something else. Any questions about this? Yes?
I have a question not really about this, but what's happening when you're debugging the process at the same time? Do you have a diagnostic window for each one, or all the information is just versus the same window?
So the question is, what happens when I'm debugging multiple processes at the same time? The answer is we have multi-process support. So when we RTM, you're going to be able to use the debug location to change the active process, and that will show you with one window all of the data for the active process. You can then change to the different process and see the data in the same window for the other process. So it's always one window, but it's multi-process aware. It's not in RC right now, but hopefully it will be by RTM or maybe update 1. We're working on adding true multi-process support.
But it's always one process at a time.
It's always one process at a time right now, yes. Yes, please.
The production environment, our application should point to the algorithmic number 4.6 or 4.5, which is required.
Let's chat about this in just a second. I just want to say this is the end of my fill you out, and I'm just going to be at the end here taking more questions. Thank you, guys.